Hello guys, it's me again. Welcome back to my channel, which is Tech and Non-Tech with SUMIT OHDAR, with second video lecture series of engineering maths. I hope you guys are enjoying it. And before we proceed, if you are new to my channel, please subscribe it. And also, after watching the video, if you liked it, please give a thumbs up and don't forget to share also to your friends, at least those who are in the second, third and final year student, and those who are preparing for the competitive exam. So let's start the video. Determinants. So the definition of the determinant is the factor which determine whether the linear system possesses unique solution or not is called determinant. So there is a motto behind to find the determinant is to whether the linear system is unique or not. So how we have to tell through the determinants that linear system is unique or not. Suppose there is two equation is given over here, two equation which is the linear system x plus b and y is equal to c1, and the second equation is a2x plus b2y is equal to c2. Now we have to find whether these two equations are, whether these two linear systems are unique or not. So the determinant is going to help us or to tell whether this linear system is unique or not. So we need to find what is the determinant. So determinant means when a1 b1 minus a2 b2 is not equal to 0, tells that given linear system is unique. If it comes 0 means the linear system doesn't possess any unique solution. So here next we have to learn how to find the determinant of any linear system. So here is general equation I have written over here. So you need not to worry much about this equation. So I will just tell the what are the term over here I have written. So here it is the element ij, and delta ij is the minor of an element aij. I stands for the row and j stands for the column. So suppose there is a matrix given, we'll just look one general matrix that how to find the determinants, and for that the element is given for that A matrix, which is the a11, a12, a13, 21, 22, 23, 31, 32, 33. These are all element of the matrix A. We have to find determinant of matrix A. So just don't bother about this equation much. We'll just find how to find the determinant. So determinant, first write down the element ij, 1 1. Here I j column. So a, first write a11 column, 1 1 element of the matrix outside, and just write the minor of that element a11. So what is the minor of the element? This is the minor of the element a11. How we have to write the minor? Means come to the matrix. So what is the minor of the element a11 is, just remove the first row, just strike out the first row and first column. So what is the remaining matrix, which is this one? This is the matrix a22, a23, a32, a33 is the minor for the element a11. Similarly, what is the minor for the element 1 2? We need to find what is the minor for the element number 1 2. Okay, so for finding the minor of the element 1 2, just strike off this row and this column. What is the remaining over here? a21, a21, a23, a31 and a33 is the minor of the element number 1 2. Similarly, we have to find what is the minor of the element 1 3. For finding the minor of the element 1 3, just strike out the first row and the last column. So what is the remaining? This is the remaining. This is the minor of the element 1 3. So for the element number 1, this is the one general equation which I already told you. I have fixed the row number 1. You can fix either column or row. So I am fixing over here I is equal to 1, and here this is the j will keep on varying. Okay, so this term is j, this is a j, 1, so j is 1, next is 2, next is 3 columns. So there is the 3 column. If there is another 4th column, means there will be one more term. Okay, so this is how you have to keep on writing, and based on that the sign will also change over here. If it is 1 1, so minus 1 to the power 2 will be the positive, minus 1 whole to the power 1 plus 3 means that is the odd, will be negative. Similarly you just keep on writing. So at the end we will be getting this one, and just multiply it, cross multiply it, this, and multiply with the corresponding element. You will be getting the determinant of the matrix. Okay, so this is how you need to find it. So before we go for the problem, there is some properties of the determinant. You need to remember this, which is very important. So first property is determinant of the matrix A will be equal to determinant of the transpose of the matrix, and determinant of product of two matrix will be equal to the determinant of individual product of determinant of the individual matrix. Okay, so the determinant of a to the power n is equal to, first you find the determinant, then you take the whole to the power, will give you the same answer. Okay, then the determinant of A inverse is equal to 1 by determinant of matrix A. Property is, okay, so K is the constant over here, scalar constant Ka and Kb. So just take the common K outside, which is here, and then remaining which is A, D, B, C. Okay, then you find the determinant and multiply with the K. This is the properties number 5th, and properties number 6th is that if K is multiplied with the all the element of the matrix, then you just take it outside to the power order of the matrix. N is the order of the matrix and A is the determinant of the matrix A. Just multiply it, and then determinant of adjoint of the matrix will be the determinant of the matrix whole to the power n minus 1. Again here n is the order of the matrix minus 1. These are the important properties of the determinant. The properties number 8. Number 8 is that suppose if they are asking you find the adjoint of the matrix adjoint an, then this is the shortcut. Just write the matrix A and multiply the determinant of the matrix whole to the power n minus 2. Again here n is the order of the matrix, will give you the adjoint of matrix A. Okay, then you have to, if you have to find what is the determinant of adjoint of matrix A, means this will give you the, first you find the determinant of matrix A whole to the power n minus 1 whole square, will give you the determinant value of adjoint of matrix A. So this is shortcut to find the determinant and adjoint of matrix A. Okay, and this is also important, the determinant of lower and upper triangular matrix. The determinant of lower and upper triangular matrix and diagonal matrix is the product of its principal diagonal element. Okay, I repeat, the determinant of lower and upper triangle matrix and diagonal matrix is the product of its diagonal element. So we'll take one example. So one example is given over here, which is the lower triangular matrix. Okay, lower triangular matrix means upper the principal diagonal element all the terms will be 0. So here it is 0, that is why it is called lower triangular matrix. If it is lower part is 0, then that is called upper triangular matrix. So this is the order of 3 cross 3. So this is the lower triangular matrix, and determinant of this matrix is just find the product of principal diagonal elements. This is the principal diagonal element, just find the product of this, means 1 cross 3 cross 4 will give you the determinant of this lower triangular matrix. Okay, so this is very simple. If you find such kind of problem like lower triangular matrix, upper triangular matrix, and some diagonal matrix, then you just find the product of their principal diagonal element will give you the determinant of that particular matrix. So we'll take one example. Okay, this is the another property is given over here. Please you remember that one. The 11th property says that the determinant of the skew symmetric matrix of odd order is odd is 0, and the even order is perfect square. So what it is saying, the determinant of the skew symmetric matrix of the odd order is 0, and for the even order is perfect square. Okay, so here one skew symmetric is given over here in the last video. So this is one of the skew symmetric matrix is given over here whose principal diagonal element is 0 0. So this is the condition, okay, for being the skew symmetric matrix, their diagonal element should be 0 and 8 transpose should be the negative of a matrix. Okay, so we satisfy. So this is the skew symmetric matrix and of odd order. This is the odd order, okay, order of 3 cross 3. Okay, and property says that for the skew symmetric matrix of the odd order, for that matrix the determinant will be the 0. Okay, by property we can write directly answer. So 12th property is the determinant of orthogonal and unitary matrix is either +1 or -1. Again, the determinant of involuntary matrix is +1 and -1. Again, +1 and -1. What is the involuntary matrix? Again, we have discussed in last video stage. So involuntary matrix is A square. When you multiply the matrix with the matrix itself will give you the identity matrix. So what I have done, just take the determinant in the both side, okay. So by the property of the determinant we can write it this determinant of A whole to the power square, and determinant of identity matrix will be the 1. So when we remove this square will give you the plus minus 1. So the determinant of involuntary matrix is either +1 or -1. Okay, this is the 13th problem, and 14th problem says the determinant of idempotent matrix is 0 or 1. So idempotent matrix means when you multiply the matrix with the matrix itself will give the matrix itself A. Okay, now again you take the determinant in the both side. Again by property we can write it this, and when you bring this from right side to left side, it will become A square, A determinant whole to the power 2 minus determinant of A is equal to 0. Now from these two you just take determinant of A common, will give you the determinant of A minus 1 is equal to 0, means determinant A either 0 or 1. So the determinant of idempotent matrix is either 0 or 1. Okay, next linear dependency and linear independency in the determinant. Okay, so we'll learn what is the linear dependency and independency in the determinant. Okay, so a set of vectors x1 x2 x3 as so on are linearly dependent if their linear combination 0 when when for not all ai is equal to 0. Okay, similarly linear dependency definition is a set of vectors x1 x2 x3 as so on are linearly independent if their linear combination is equal to 0 only for all ai is equal to 0. Okay, when you read this definition of linear dependency and independency you will get confused. Okay, so I'll just tell you the shortcut to find what when the set of vectors is called linear dependency and when set of vectors is called linear independency. Okay, so okay, in coming we'll see what is the linear dependency and independency. Okay, I'll just tell you the dependency means when we can write the one vector like suppose when we can write the like to scalar multiple of other vector. If we are able to write one vector in the scalar multiple of other vector means that system is linear dependency. If we are not able to write in this form means that is independent of each other. But if we can write it one vector in the form of scalar multiple of other vectors means that is the linear dependency. Okay, in the coming we'll see one examples. Before that we'll just again write the properties of the dependency and independency. If any two rows or column are linearly dependent then the determinant of that matrix is 0. Remember that if any of the given matrix and in that matrix if any of the two row or column is linearly dependent, if linearly dependent then their matrix will be 0. Determinant of that matrix will be 0. Determinant of that matrix will be 0. As for the example, suppose there is one vector x1 of element 1 2 1, vector x2 of element 2 4 2 and vector x3 of element so now we can write this vector x2 scalar multiple of vector x1 means 2, just take the common, what will be the remaining inside 1 2 and 1 which is the x2 is equal to 2x1. so we can write it the scalar multiple of x1 means there is a dependency between these two x2 and x1. so determinant of these two vector will give you the 0 means x2 minus 2x1 is equal to 0. Okay, similarly here 3 vector is given over here. One is x1 of element 1 2, x2 of element 2 5, x3 of element 3 7. Okay, so can we write any of the vector in the form of other vectors? x2 will give you the x3 means there is a dependency between these vectors. so determinant of this will be the 0. that is what meant all about the linear dependency. Okay, so here I have written x2 is equal to kx1 means linear dependent and x3 is equal to a1 plus a2 is equal x1 x3 are linearly dependent. Okay, so if one vectors is written as the this is what I was talking about, the shortcut you read this will be understood to you. Okay, so if one vector is written as the scalar vector of other it is known as linear dependency. Okay, dependency. Okay, so moving ahead, there is a two vector x1 of element 1 2 1 which we can show it as general a1 b1 c1. Similarly vector x2 2 4 2 as general we can say a2 b2 c2. when you write these two vector in the form of the matrix we can write 1 2 1 2 4 2 of the order 2 cross 3. Okay, now you have to find is there any dependency or independency. so we learn one technique to find how it is dependency means here x2 we can write 2 times of the vector x1 means there is a dependency is there. Another technique to find if there any dependency or not, just you find the ratio a1 by a2, b1 by b2 is equal to c1 by c2. If it is so, it will give you the linear dependency. So you can check any given matrix whether it is linearly dependent or independent. Either you go with this, or you just find the ratio of the corresponding element, okay, corresponding column. With these two we can tell whether the given matrix is the linear dependency or not. If there is a dependency, you know what would be the determinant value. If there is independency is there, then what is the determinant value, okay. So, and third technique to find the dependency is and third technique to find the dependency is take the possible minor of 2 cross 2. Okay, so what is the possible minor of this 2 cross 2 is, these are the possible minors, either 1 2 2 4, 2 1 4 2 and 1 1 2 2. Okay, what is the possible minor means, either you just take this one possible minus 1 2 2 4. Okay, second is 2 4 1 2, and then third one is this 1 2 1 2. Okay, if find the determinant of this all possible minors is coming 0, means there is a dependency. Okay, so all possible minor of 2 cross 2 is coming 0, means there is a dependency in their vector. Okay, this is the third technique to find of the given matrix is whether dependent or independent. Okay, now question, just will solve one questions or two vectors is given of vector x1 of element 1 2 1, vector x2 of element 2 4 6. Okay, now you just apply one by one. First you find the ratio of the corresponding column. The ratio is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So this is one technique to find dependency. But when you do that for this particular vector x1 and x2, we'll be getting a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, means there is a linearly independent. They are linearly independent. And just apply the second technique, find all the possible minors as I discussed above, 2 by 2 possible 2 by 2. So we don't have to find all the possible minors. If in the first possible minors itself you are not getting 0, means you just stop there, that will be automatic linearly independent. Okay, so in the second possible minors itself is coming not equal to 0, means there is independency. Okay, so this is the one of the technique. And one more technique is if determinant is not equal to 0, then all the vectors in A is linearly independent. Okay, so one more technique, just find the determinant of the given matrix. If it is coming not equal to 0, means by default blindly you just tell that the given matrix is linearly independent. Okay, I repeat this term, you find the matrix of the given determinant of the given matrix, and if it is coming not equal to 0, means that is linearly independent. So this is, I guess, easiest one to guess whether the given matrix is independent or dependent. So once again, if the determinant is coming not equal to 0, means blindly you tell that given matrix is linearly independent. Okay, example, just I'll explain one example and remaining you try to do by yourself. I'll scroll down. You can write the questions, you can see the questions also, or if you have any standard maths book, you just try to solve it. Otherwise you just take the GATE previous year questions and solve it. Okay, most of the questions is GATE previously year asked question is there in my note. Okay, so we'll just solve one question. Okay, there is a matrix is given, a determinant value 2 1 3 minus 1 2 1 1 3 4 is equal to 0 of order 3 cross 3. See, when you write the row number, look at this determinant third row we can write summation of row 1 plus row 2, means there is a dependency. Then you blindly tell the determinant of the given matrix will be 0. Okay, similarly if you look the column 3 also we can write it. Column 3 also we can write it summation of column 1 plus column 2, means that means also. Okay, next, elementary transformation. Elementary transformation could be in two ways, either row transformation or column transformation. Row transformation or column transformation. So why we need the elementary transformation? In sometime in the exams the matrix given is won't be easy. For that you will be able to find the determinant or whether there is a dependency or independency. For that here it comes elementary transformation, through which we can make the complicated matrix into the simplest matrix, through which we can find easily whether the elementary transformation, through the elementary transformation, whether the given matrix is there any dependency or independency, or either find the just determinant alone. Okay, so rule, there is some rule for the elementary transformation. First rule is that elementary transformation could be either row transformation or column transformation. Okay, so rule number 1, for the rule number 1 says if we interchange any of the rows with another row, okay, the row 1, row I and the row Z, if we interchange any of the row, the determinant will give you the negative value. Okay, there will be the negative determinant will be the negative. Rule number 2 says that if we can write the row ith row is scalar multiple of jth row, then the determinant of matrix will become scalar multiple of k into determinant of matrix A. Similarly for the rules 3, if Ri, we can write Ri means ith row plus lambda, which is the scalar, into jth row, then the determinant will be the same. Okay, so these are the some elementary transformations rule you please keep in your mind, and same goes for the column also. Okay, so 2 marks question is given over. Just look at here, the matrix given is 3 4 45 7 8 105 9 2 135. So here question itself is giving to apply the elementary transformation to this and see also, or simply you just take the 15 common. Okay, this will reduce in the simplest form, which will be the 3 4 3 7 8 7 9 2 9. Okay, with this if you look at the column number 1, okay, and the column number 3 is same, means there is a dependency. So automatic there is a dependency in the given matrix, means what? If there is a dependency, means the determinant of that matrix will be 0. So you don't have to find the things and make the things complicated. So I'll suggest you to please do remember all the properties thoroughly, and should be in your tip of tongue or in your brain somewhere. It should reflect as soon as you read any of the questions. Okay, so this is how you have to use the things in exam for getting the solution within the time. Okay, so remember that everybody would be able to solve it, but things is that those who are able to solve within the time will go ahead. Okay, so for that you need to remember all the properties of the determinant, okay, and then matrix. So there is one more question is given to find the determinant of the given matrix. Coming to the 3 cross 3 matrix is bit easy to find the determinant even in a traditional method also, but coming to the order like cross 3, suppose here it is given 4 cross 4, means how we have to find the determinant of the matrix. Okay, in such kind of questions, first you try to find is there any rows or column which contains maximum number of zeros. Okay, if the matrix of order 4 cross 4 or more than this, first your task is to find if any of the rows or column contains more number of zeros. Okay, so if you look at this matrix, if you will find the first row itself contains 3 zeros. Okay, so if you find such cases, now your task is to just fix that row and find the minors or find the determinant, you can say. So what would be the -1 whole to the power for the element 2? Write the element 2 -1 whole to the power. This is the position of 1 1. Okay, first row first column, so in the power 1 plus 1. Okay, 2. Now you just remove the first row, just strike out the first row and strike out the second column. You don't have to strike out really, just for the easy explanation I am doing it, but you have to do this in your on your judgment, or it should be inside your brain. You should not really cross the things. You just do strike out the first row and the first column. Then what is the remaining term? The remaining term you just write over here, which is again this one. Again you just find, is there any maximum number of zeros? Okay, so look in the column first there is a maximum 0, which there is 2 0. Okay, now -1 whole to the power 1 plus 1 will give the positive, so it gone. So just write the 2 as it is over here into 1. Now write this one outside. Okay, again it is in the position 1 1, will give again the positive value. Then find the next left out things, which is 2 0 6 1. Okay, now just cross multiply it. 2 1 ja 1 and 6 into 0 will give you 0. When you multiply it, you will be getting the answer, which is the 4. So this is how you are supposed to find the determinant of the order 4 cross 4 or more than that. Okay, you need to find the maximum number of zeros or in the rows and column, and then you just fixed any either row or column and proceed with just finding the minors, and at the end things will be easy and you will be getting the answer. Okay, similarly here one questions which been already asked in the GATE exam for 2 marks. This was the matrix given over here. Okay, for finding, you have to find the determinant of this matrix. Okay, now just 4 cross 4. So your first task is to find the maximum number of zeros. Okay, so if you look at in the row 2, second row there is a 2 row. If possible, try to make it 3 rows. If it is 5 by 5, try to make at least 4 zeros in that any of the rows, just by doing the elementary transformation. Okay, so here what I have done, column 3 is equal to column 3 minus 3c1. When you do that elementary column transformation, you will be getting the maximum number of zeros in the row number 2. Okay, now you just fix the row number 2 and proceed. For the row number 2, what is the position of this? Is the 2 1, which so -1 whole to the power 2 plus 1 will give you the negative value. That is why I have written over here negative into 1. Then just strike out the corresponding rows and column. And write the remaining term over here. Okay, then similarly you proceed again, find the maximum number of zeros. You will be getting the answer which is coming 88. Okay, I hope it is clear. You please try to do it by yourself once again. Okay, there is again questions, 2 marks questions, GATE questions. Question was given. Okay, such type of determinant is called, matrix is called Vandermonde matrix. Okay, if it is in such pattern, I would suggest you don't go with elementary transformation and all that, and don't try to convert it into zeros and all that. So there is a shortcut for this one. Okay, the shortcut is that Okay, 3 minus 2, just subtract this one, just focus in. So 3 minus 2, next 4 minus 2, you just look at the pattern, next 5 minus 2. Okay, this is done. Next you write 4 minus 3, next 5 minus 3, and the last you write 5 minus 4. 5 minus 4, sorry, here it is not be visible to you because I am using my finger. Okay, so I'll explain you. First you write the 3 minus 2, next 4 minus 3, next 5 minus 4. This is one pattern. Then again you repeat from here, 4 minus 3, 5 minus 4. Okay, now again repeat last, which is the 5 minus 4. Okay, for such kind of Vandermonde matrix, you don't have to do all these things to get the answer. There is a shortcut I have written over here. Okay, you just please go with this shortcut. You write that matrix and just look at this pattern. You will understand what I have written over here, and please follow this one for finding the determinant of the Vandermonde matrix. Okay, and some of the shortcuts is given to find the determinant. So if the matrix in such format, so determinant will be product of A, B, C, D into 1 plus 1 by A plus 1 by B plus 1 by C plus 1 by D. Okay, these all are shortcut. There is nothing to teach or explain, so you just please keep that in your mind. So if matrix is given in the cyclic form like A, B, C, then again B, C, A, C, A, B, then the determinant value will be this one, 3ABC minus AQ minus BQ minus CQ. Okay, similarly, if the matrix is in this format, then the determinant will be A plus B plus C plus 1. This is how we Vandermonde matrix I told you about. This is how you have to find the determinant of this matrix is A minus B minus B minus C into C minus A. Okay, for that also each example is given over here. So this is just go with the example. It's very easy. Okay, and if you like the video, please give thumbs up, and also don't forget to share it with your friends. And with this I'm signing out until we meet again with another topic, and next video I'll be teaching you how to find the rank of a matrix. Okay, with this I'm signing out until we meet again. Till then, bye bye.